Good afternoon, ladies and gentlemen. Welcome to TechGig webinars, our endeavor to empower techies. We believe that sharing of knowledge is the key of enhancing our performances and for our growth as professionals. With this principle in mind, TechGig has initiated a series of webinars conducted by industry experts to give a crisp insight of various domains. Topic for today's webinar session is Java Design Patterns, Strategy Pattern. We are delighted to have Mr. Hemant Kumar Dugar, Training Consultant at Login to Java as our guest speaker. Hemant is a motivated achiever with more than 15 years of significant and progressive experience in IT. He is a PMP certified professional having a sound base for core concepts in managing projects and processes at various knowledge areas, also having extensive knowledge of managing projects using various PM methodologies. Most of the projects he worked were in Java, J2EE and related technology, and has completed some of the finest work in C# and PHP. Gentlemen, this presentation will continue for next 45 minutes and we'll take your questions after the presentation. In the meanwhile, you can post your queries through the chat pane available in the webinar software. Without further ado, I introduce you to our guest speaker, Mr. Hemant. Mr. Hemant, can you hear us? Mr. Hemant? You can start with your presentation.
Hello, am I audible?
Mr. Hemant, we can hear you. You can go ahead.
Okay, right.
Yeah.
Good afternoon, everyone here, and also happy Valentine's Day to all of you. So our today's topic is basically strategy pattern. Let's look at a context. Different algorithm needs to be applied on some values. Algorithms. We will take simplest form of algorithms to understand first the strategy pattern. We will take two simple values A and B, and we need to do some calculation on these two values A and B. The operation will be either addition or subtraction or multiplication or division. So we have different algorithms that needs to be applied on some values. The algorithm will return a value to the client by applying some logic or calculations on these values, right? Develop a module to implement these algorithms in a way that on request from client application will execute proper algorithm and return the resultant value to the client application. So if we look at this scenario, it seems to be a very easy sort of implementation that can be done. Give it a thought and we will discuss shortly on what can be the possibilities of implementation. Suppose you are developing some application where you need this particular algorithm to be calculated, one out of several algorithms. So suppose this is your class when you are developing this particular module. depending on the requirement or depending on the way you code, at this position you need to apply the algorithm. So either you can implement your calculation within this particular class as a separate method, or inside your code, or maybe as a separate class, right? Even if required, you can have a separate utility package where you can develop this particular class or algorithm. Right. It can be a separate module, it can be a separate package, or it can be altogether a separate jar file where you can develop this particular calculation, where you need to do one out of several calculations. To make it a separate jar, obvious, it is very useful when you distribute the same API to different applications. So depending on your requirement, you can develop. This is your client application. You can code for your algorithm here, or in a separate class, or in a separate module or package, or as a separate jar, right? Although there can be many possible solutions, seems to be very straightforward. I think you all agree on this. Separate out the implementation logic in a class or a module or a package or a utility class or as a separate component from the client code that uses it. So looking at this particular scenario, this particular context, a static class can be created to have a method get calculated value, and where you can pass two different parameters A and B on which you need to perform some calculations, and will have if, else if or switch case ladder to handle the different algorithms. This is basically comes in every developer's mind that this can be a particular solution for this problem. So let's look at the example code for this solution. We have made the class final because we don't want any sort of instance for this class. Although making final will prevent class from instantiation by its subclasses. So that's why we made it final. We have taken two constants, calculate sum and calculate product. They are basically type of calculation that should be performed looking at the context. Sum is 1 and product is 2. These are the constants. We have made the constructor private so that direct instantiation won't be possible. Then this is your method get calculated value, where you pass first the type of the calculation that you need to perform, and then the two values A and B, these two values. And here goes your code, where you check if the type of the calculation is sum, written A plus B. Otherwise the type of the calculation, if it is product, you can written A into B. Otherwise you can throw an illegal argument exception. So this is the simplest way of implementing. It can be we have created a separate class for it, that is class calculate. To understand the strategy properly, I have taken the algorithm very simple calculation A plus B and A into B. But this can be a set of around 100 statements for a particular algorithm. And here also there can be 50 lines of code. So we are not making it much complex to understand the algorithm, but we are concentrating on strategy. So I have taken very simple example. Let's see the code, how this can be used. So it's very simple. This is your client application where you want to use this algorithm. There can be many statements over here. There can be many statements over here, but in between you can use this algorithm. If you want to calculate sum, calculate, this is a static class, so calculate.get calculated value, and you can pass what type of calculation you want and the values on which the operation will happen. Similarly for product, you can use like this. So this is a straightforward simple implementation for the given problem. Is it easy to expand? Is it easy to test? Is it easy to reuse? Is it easy to maintain? Although it is easy to create for the first time, it is a straightforward implementation, very simple implementation. Just give it a thought. We will be discussing it in a couple of seconds. So this is your class. This is the line where you are using the algorithm, one algorithm out of several algorithms. You can develop that particular portion inside this class, or we have developed it in our example outside of this class as a separate class, calculate. Or it can be a separate package altogether where you can have your class, or you can have a separate module as a jar where you can have this class, right? Now in our current example that we just saw, if you need to add one more algorithm, what you have to do? Suppose we have two calculations, addition and multiplication. Now we need to add another algorithm for subtraction. So you need to modify this particular code that you developed in a separate class or as a separate module or as a separate package. So your actual code needs to be modified. So it is not that easy to expand. Now when we come to testing, as you are modifying your actual code that has all the algorithms, you need to test each and everything, right? Easy to reuse, it is not that easy to reuse. Although even if you are having it as a separate component and you are having some other applications also using it, so this jar needs to be modified for the new algorithm and it needs to be shipped to all the clients that are using this jar, all the client applications. Easy to maintain, it is not that easy. We will shortly discussing all these points when we understand the strategy properly, and we will compare how strategy will improve this particular scenario. In our current code that we just saw, we are not that easy to expand, test, reuse and maintain. Let's see this strategy. Strategy is a behavioral pattern that groups several algorithms in a single module to provide alternatives. The same context that we just discussed, also known as policy. The strategy pattern defines a family of algorithms encapsulating each one and makes them interchangeable and dynamically, basically. So a strategy lets the algorithm vary independently from the client that uses it, basically. The example that we just saw, if you can think of a simple non-object oriented programming language like C, that can also be implemented in the same way, either in the separate .c class or within your class as a separate method that can be implemented straightforward. So we have not taken any advantage of object oriented in our example that we just saw. The strategy design pattern embodies two fundamental principles of object oriented. What are these two fundamental principles that actually strategy uses is encapsulate the concept that varies and program to an interface, not to an implementation. So let's see how strategy will go. Implement a strategy interface for your strategy object. The strategy interface defines your strategy object's behavior. What it means, you should have a strategy interface and define some methods that will depict the behavior of this interface, and then implement concrete strategy classes that implement the strategy interface as appropriate. So even if now you can think in object oriented terms, this seems to be a simple implementation where you will be having an interface and some of the methods and concrete classes will be implementing the interface. The class diagram should be similar to this, where we are having iStrategy interface and there are some operations, where we are having now concrete implementation as concrete strategy 1, concrete strategy 2 and any number of implementations. Client is using this interface. Through this interface it is using one of these concrete strategy in its code. I think this is easily understandable. The implementation will be similar to this, where we will be having an interface. I calculate strategy 01. I have taken this 01 because I will be taking few more examples. So this is our first example of strategy. That's why I have taken 01. So our strategy name is I calculate strategy 01. And this is the first implementing class, calculate sum 01, that implements this interface, and where we have a method, get value method implemented in the concrete strategy, where we are returning a plus b. Similarly, another strategy product, calculate product 01, implements I calculate strategy 01, and again implementing the same method, get value method, and which is returning a into b. So we are having one interface, two classes, and you can easily imagine how we can use it. So this is our client application which is using the strategy. I calculate strategy 01. This is the reference for this strategy, and we are taking an instance of new calculate sum 01. So to calculate the sum, we are taking concrete implementation of sum, and then cal 01 dot get value 10, 15, cal 02 for the product, and this is the code to use the get value of the product. So I think this is easy to understand how the strategy is implemented. So let's discuss again. Now, what is the implementation? This is our client class. We are having one interface and two classes implementing it. In our separate module or in a separate package, the same implementation, or maybe within our own application we can have these things, right? Now, is it easy to expand? So I think now it's very understandable that it can be very easily expandable without changing these code lines. You can have a separate class within your package. This class will implement this interface. Maybe or maybe outside this package, or maybe outside your component, or even say this is client using module or package. Client can itself implement a strategy by implementing this interface. So you need not to ship the module or jar again to the client. You just need to send either the patch or develop that particular concrete within your application. So it is easy to expand. It is easy to test also, because you are developing, you are creating separate code. You need not to test the already working functionality. You just test the new one. It is easy to reuse. You need not to supply the new jar. You can just give a patch to the client. So just supply this patch and this will work with all the clients that are using it. So don't get confused with this diagram. I am taking 2-3 examples where you are having it in a separate package or in a separate jar component itself. In all these scenarios, this is very easy to expand, test, reuse, and so it is easy to maintain also. And definitely in long run, it is less costlier to use strategy wherever strategy can be applied. So let's see example working live. So just have a look. This is no strategy application client. Our original example where we were having calculate strategy, not calculate strategy, calculate class separately to calculate A and B and if-else-if ladder to return the proper value, and we are passing the type of the calculation. And this is the client application, and I am just executing it, and you will see the output that will come to be calculated value 10,15 will be 25, and the product 3 into 12 should be 36. So this is the output. Now let's see our strategy 01 implementation. This is our interface. I calculate strategy where we are having a behavior get value, and this is our calculate sum, which is implementing I calculate strategy 01, and this is the method implementation, concrete implementation, where returning A plus B, and this is our client application which is using strategy interface. This is the strategy interface. cal01 is the reference, and cal01 dot get value with the concrete implementation of sum, and here concrete implementation of product. I am executing this, and the same result will come. So this is the output. Sum 25, product 36. Now let's look at some of the variations in strategy. We have already seen implement a strategy interface for your strategy object. The strategy interface defines your strategy object behavior, and we have some concrete classes. Now you can have concrete strategy as a singleton objects. So if you see the strategy example that we just saw, let me show you again. See this code. What we are doing, we are creating an instance of strategy. Suppose there is some real-time application going on where we have millions of records per minute, and we need to apply some strategy to that stream of data in real time. Can you think of how many objects will be created? So we need to check whether we need the instance or we don't need the instance. In our application where we are having just two values A and B, and we are calculating, we are doing applying some algorithm on A and B, we don't need instance, separate instance for each strategy. We just need to pass two values to a method, and that will return the calculated value. So for our scenario, this is not required. Just think of millions of objects creating every minute, unnecessary wastage of resources, as well as garbage collector thread to clear those objects. So that will slow down the performance of real-time application. So we can have our concrete strategies as a singleton object. So just to I think most of you will understand singleton. I am just explaining. Singleton is basically a design pattern that allows to create only one object of a class, not more than one object. And every client will use that single shared object. And I have taken that session earlier, so you can find, I think, in somewhere in the recordings available at TechGig. So there are two kinds of classes, singleton or n-ton. The example that we just saw was n-ton. Now we will see the example of singleton. So this is strategy implementation with singleton. To make a class singleton, make the class final, because if final is not there, any class can extend and create the object. So we have made the class final, implements I calculate strategy 0 to, then we have taken the only object as a static reference within the class, and that object will be instantiated as soon as the class gets loaded into the memory, because we have taken it static. Then we have made the constructor private so that outside the class the instance cannot be created at all. And then we have a static method that will return the only instance. See some. This is the instance that will be returned, the only instance. So you cannot use new keyword. Instead you have to use get only instance, and it will give the only instance available for that class, and it will not allow you to create any other instance. And here is the method that goes get value. That is the concrete implementation of calculate I calculate strategy 0 to. 0 to is used for our second example. So we are implementing the same strategy. So we have created concrete strategies as a singleton class. Now the client code, the changes will be, instead of new, you can use calculate sum 0 to get only instance, calculate product 0 to get only instance. So for the application example that I have taken for a real-time data processing, where we need to apply strategy, and it is basically the requirement that the values that needs to be that on which the algorithm needs to be performed, there is no need of instance of keeping those values, so you can just directly call the singleton instance, and this will not create unnecessary objects, and this will be much better in performance than our earlier example, the first example that we took. So let's see this example working. So this is our client strategy 2, where we are using the only instance, and we have singleton implementations for the strategy calculate sum 02. I am taking one example. The similarly product 02 will be available. So this is final, then this is a static method having containing only instance of the class, and the constructor is private, and get only instance method, and this is our concrete implementation of algorithm. So if I run this particular application, it will give the same result, the 25 and the 36. So let's see the output. The same output will be there. Now another variation that can be possible with the strategy, you can have your context class to maintain the private reference to strategy object. Now what is context class? In your context class, implement public constructor setter and getter methods for the strategy object. This is very handy and useful if algorithm needs some context data to work upon. Suppose there are some common data that needs to be applied on algorithm in different contexts, where in the same context, I mean the data is same, but we need to apply different algorithms on the same data, so we can put those data in the context class. What is important here is have a setter method at least in the context class, so that you can change the strategy within the same context. So let's see the example. Now this is our I strategy 03, the same behavior get value, and now we are having a strategy context 03, where we are having a reference for our strategy, first thing. Then we are having a constructor for this strategy context, where we can pass on our initial first strategy that will be assigned to this reference. So initial strategy can be available through the constructor, but later on, if you need to change the strategy, you need this method to be used for the same context. Definitely the missing thing is here at this place, the context data, but you can easily imagine that there can be some data common to all these strategies that can be we can have those data over here, right? And then we have a method execute strategy, which will execute the strategy on two values A and B. Cal strategy dot get value. This is our implementation, concrete implementation of strategy, where A plus B or A multiplied by B or maybe other operations, other algorithm can be applied. This concrete operation will be applied on this strategy that will pass either through the constructor when this context will be created, or through the setter method when we want to change the strategy for the same context. So this is another variation where we can have the same context data available to different strategies. Now simply you can imagine the use where what we can do is we can, for the first time, we can create a new context where we can pass our strategy. Some get only instance depicts that we are using a singleton strategy object, and some. Similarly, now we need not to take the separate instance for the context if we are having, we need to use the same context. So same context dot set strategy, and we can pass on another strategy like product, and this will be executed on product. So another advantage that you will have in your application, suppose you need to perform the same the same set of algorithm on a different context in the same application. So you can have two different contexts working on strategy in the same application. So you can have another context object for another set of data. So this is another variation that can be possible with the strategy. More possibilities. Now you can think of other possibilities also. Suppose you cannot, you can have concrete strategy as singleton. We don't need the singleton behavior, and we need to have a separate instance. Maybe the application requirement is like that. So you need to drop down the singleton behavior, and instead of using get only instance method on concrete strategy, you need to use new concrete strategy. So this is the class diagram where the client is using context. Context is having a strategy object within the context. And strategy object is basically the implementation of concrete strategy. An additional operation here is required is set strategy in the context. You can change the strategy dynamically within your application for the same context. So looking at these variations, think there can be more variations of strategy, or maybe some other patterns also can be patterned depending on your application requirements. So think twice while implementing and modifying strategy or any of the design pattern to match your requirements. What I mean to say is, lot of code is available around, either on the net or on the books or with some already coded program. So don't just copy paste the code and modify, just think whether it is required. For a simple example, if you are working on a real-time application and you are creating a new instance for your strategy every time, just think whether that instance is required or not. If it is not required, you are creating unnecessary thousands of objects, which is slowing down the performance tremendously for your application. Now let's see a Java API example for strategy. The Java util.zip package contains some classes that use the strategy pattern. There are two basically classes, checked input stream and checked output streams. These classes actually uses strategy pattern to compute the checksum on byte stream. Both these participate as client classes in the strategy pattern in Java util.zip. Constructor of both classes takes checksum as argument, where checksum is an interface that participate in abstract strategy role, and these two are the concrete implementation of strategy checksum interface ADLER32 and CRC32. And these classes participate as a concrete strategy in this role. So this is a Java API example. Now just have a look at this. See the variations. Maybe the context is not required. Maybe your strategy can be singleton or n-ton, or the combination of both. The context will be required, or you can have a singleton or n-ton behavior. Related patterns. Flyweight provides a shared object that can be used in multiple contexts simultaneously, whereas strategy focus on one context. So this is another flyweight pattern that is similar to the strategy pattern, but it can be used in multiple contexts simultaneously. Null object. The strategy pattern is often used with null object pattern. Null object pattern basically reduces the chances of null pointer exception. Template method manages alternative behavior through subclassing rather than delegation. That what we saw was the delegation. So template method is a pattern that manages alternative behavior through the subclassing. And state can activate several states, whereas strategy can only activate one of the algorithm. So these are some of the related patterns. So let's have question answer round. I just saw I'm looking at questions that we have. If I calculate, this is from Anand. If I calculate strategy 03 doing division, I need to include this class in the jar. Can you explain why it is easy to reuse? Anand, we need not to include that in jar. We can separately compile it and ship it to our customers as a patch. That I think I have explained it. Is it, another is Chetan Shah, is it necessary for the client to know about all the concrete implementation of this strategy? Definitely it is necessary for the client to know all the concrete implementation that a particular component is having, which they need in their application. What I mean to say is, a component having several algorithms as a strategy implemented, it is not necessary that all client needs all those implementation. Also, you need not to go in detail of the concrete, how that is implemented. That client need not to worry about. Client just take the instance or the singleton instance of concrete and use it. Bhavna, when should context in strategy pattern be used? Yeah, I explained it earlier also that it might be possible that some of the common data that might be required by more than one strategies to work upon. That data can be put into the context. Is there any thumb rule to know when to use context or singleton? Pradeep, I think Anton or singleton can easily be imagined when you work upon strategy. If you need instance, you have to go with Anton, but simple calculation, simple algorithm that directly works on the data and then calculates some value and returns it, I think singleton behavior is sufficient for this strategy. Any question that is related to comparison of patterns, I think it is not good over here to reply on those, because many of you will not understand if you are not knowing the other patterns. So I am not replying to those questions. Can you please explain strategy pattern by using Java API? This is from Nayak, Jyotiranjan Nayak. Java API, I have taken example of I have already taken example for checksum, where the checksum is the interface and two of the classes CRC32 and ALDER323 some class is implementing the strategy. That is basically used in CRC check for the stream that is passing through the some of the data that is passing through some of the streams. So it is internally using, Java is using to check the checksum. If we are having some requirement like we need to add new methods, behaviors to an existing behavior, how can we with the strategy pattern, can we implement the same strategy pattern? Jayashri Ghosh. Now it depends, Jayashri. Basically, if the behavior is common, existing behavior is common to the new behavior that we need to implement through strategy, the existing behavior can be moved to a super class, to a basically base class, and your concrete strategy can use that in the subclasses and give the additional algorithm behavior in the concrete implementation. So there will be a layer in the strategy pattern implementation for the behavior, inheritance layer basically. Bhupesh, so we can say encapsulation is the core in the strategy pattern. Bhupesh, I think encapsulation is core for many design patterns or the code examples that you see in the Java, because it is one of the main principle of object-oriented. Inheritance, encapsulation, interfacing, these are a few pillars of the object-oriented. Luca, what are the defects, limits of the strategy pattern? As far as limit is concerned, I don't think that is there any defect or limit in the strategy pattern, except for that instead of straight coding we are using object oriented, and that is bit difficult to understand. Anand, what do you mean by delivering a patch? Okay, Anand, suppose I am developing a component, and there are around hundreds of clients that are using that component, and that component is a jar file. and I am using somewhere inside that component a strategy pattern and many other patterns. So it's very easy for me to give a patch. Means what I can do, I can use the same jar and I can create a new concrete class in a separate project, compile it, make a new jar and distribute it to all of my clients. The advantage that I have is, otherwise I need to test the whole component. Instead, I need not to test the whole component. I just make a new small component, that is patch, and test it properly and deliver it to all of my clients. So you normally come across when you receive patches. So that is very easy in strategy pattern.
Welcome to GoToWebinar, web events made easy.
Taken to make the foolproof. Bhavna. If your requirement is for strategy pattern and you are using the strategy pattern, I don't think is there any case of any sort of failure, unless otherwise you need to use null object pattern.
Welcome to GoToWebinar, web events made easy.
Jayashri Ghosh, can we get some more explanation on using context regarding this strategy pattern? I will try to explain it again. Say this is your interface and you are having concrete strategy 1, concrete strategy 2, and this is your context. Your client application basically needs to apply those algorithms inside the application for some of or the other reasons, and some of the data will be different for all these strategies, but there are some data that are common to all these calls for the strategy. So you can have those data inside the context. You call the context with the required common data values. My voice is echoing, and the context data can be made available to strategy through the context. So in this way you can use.
Mr. Hemant, if you can, your speakers are on. That's the reason you are able to hear it.
No, my speakers are off. Actually, I am using headphone.
Okay. Because we are also getting a double voice.
So somebody else, I think somebody's mic is on, which is having speaker. Okay, so I think 1 or 2 more questions I can reply and then we can conclude. Shall we achieve strategy pattern by using abstract classes and interface? Yeah, definitely. For the common implementation, we can have abstract classes, but strategy should be implemented through interface only. There are few questions that are related to programming scenarios, so I am not replying on those because whenever you program on a situation, you should at that time you should decide on those things. In a large scale application, what optimization can be done in strategy, Luca? Okay, large scale application. Let me explain it. So what I mean, I understand is large scale application is not the issue. The issue is that if there are many strategies, say hundreds of strategies. So strategy 1, strategy 2, strategy 3. So you need to check if there is some common code, because that will be a duplication of code in all these strategies. And duplication of code is always prone to errors. So what you can do is you can have a either use the context for the common implementation, or you can have a superclass for these three classes, or for the group of the strategies that have common code, and implement that common code over here. So this complete will be concrete, then concrete implementation, where some of the portion of code will be at the superclass and the remaining code will be over here. So the code duplication can be avoided. So I think I have gone through almost all the questions. How will the context object obtain an instance of strategy implementation to delegate to? Context object will be having instance of strategy either through the constructor or through the setter method. Is there any cons for the design pattern? I don't think if the requirement is for strategy, you should go with the strategy design pattern. Shall we archive strategy pattern by using abstract classes and interface? I couldn't understand this problem properly, this question. Chintan Shah, can we give a real world example where we may implement strategy? Yeah, Chintan, there can be many places. Whenever you need to apply one algorithm out of several, you can go for strategy. For example, suppose I need to convert my input data into either JSON form or into some sort of XML form or into plain text form. So conversion of my input data to three different forms of data. I need one of these three at a given run. So I need to strategy at that point. So we should go for strategy at that situation. Anil Kapoor, context is the application context, or you are just using the reference to explain? No, this is not application context. This is a context of the strategy where we need different strategy to use the same context. Same context means the same data to work upon. So this is not application context. So I have done with all the questions. How exception should be handled from the different strategies? That depends whether you want to log the exception or you want to throw the exception. If you want to throw, you should maintain those throws clause in your interface. You should mention there. How the strategy pattern different from factory pattern? I think comparison, as earlier I have told, we are not taking the comparison. But these two patterns are similar in structure, but factory pattern always gives a new instance of the object. The purpose is altogether different, where the strategy you need to apply one algorithm out of several. Yeah, thank you, Nayak. One more question from Chintan is, in our context example, isn't our data different? Yeah, definitely, Chintan. In our context example, we have used A and B. I have already mentioned that we are missing the context data in our example. I have shown you how the context can be used if there is a requirement of having a context data, and I have already shown the place where we can have the context data. But in our example application, we haven't taken any context data because the purpose is not the complexity of the algorithm, but the purpose was to explain the strategy. Yeah, thanks Gupta, Saurabh Gupta. What are the alternatives for handling new requirements in strategy pattern? Pradeep. Pradeep, it again depends on the implementation. Basically, if you are creating strategy in your own application, or whether it's a separate package or maybe it's a separate module or maybe a separate component, if you need to create a new strategy, just implement that interface. If you need to modify some of this strategy, just modify that particular class only. So new requirements, what I understand is new algorithm is required. So implement the interface, and if you are having some abstract class for common behavior, use that. Yeah, thanks Ganesh. Where exactly this pattern comes into picture in web application? I think this can be easily imagined that in web application we have basically three tiers. At UI level, if you are using JavaScript, it might be required to use one algorithm out of several, so you can implement this strategy in JavaScript. Or maybe at middle layer or at data layer also. So anywhere it can be used. It is not necessary that a strategy pattern comes only with the Java. You can actually, in any object-oriented language, you can implement this strategy, but the way of implementation might be different. Or the design patterns normally applies to all object-oriented programming languages with the limitation, within the limitations of that particular programming language. Any more questions?
We'll take just 2 or 3 more questions here now. Rest of the questions we'll take offline.
Okay. Thank you, Shruti. Yeah, thanks to all of you. Vinay, thank you. And thanks, Chintan.
We're done with almost all the questions. So thanks, Mr. Hemant, for your informative session
Yeah.
on Java design patterns and strategy pattern. It was indeed an enlightening session. I would also like to thank our participants for their support in this making this webinar a huge success. The recording of this webinar will be available on techgig.com by tomorrow. Gentlemen, the next session in Database Development Series is happening this Thursday, 16 February at 3 p.m. Topic for the webinar is Demystifying DB2 Data Sharing Capabilities on Mainframe. We'll be having Captain Uday Prasad, Delivery Manager at Tech Mahindra, as our guest speaker. So see you all on Thursday at 3 p.m. Till then, have a nice day. Thank you.
Thank you.